So, this topic is about functions. Now, this is pretty much the basis or the foundations of pretty much all of mathematics is pretty much based on this concept of functions. Now, functions exist everywhere. A couple of examples that we're going to see here. We're going to see a bicycle speed. We're going to see a rocket projectile. So, we're going to see a rocket here. And car speed, like distance it traveled. Another kind of concept of what functions are in this topic is we can look at the stock market, which it goes up and down, depends on the demand and supply. Um, we can look at functions, and if you're taking out a loan for a house and you want to figure out, well, in 12 months, how much would I pay? So functions are pretty much all the way around us, and we're going to get to the definition here in a little bit, but I want to show you about 3 examples of where you see functions pretty much in real life, because that's kind of what math is. You need to express things in real life situations. So let's do the first example before we do the definitions. Well, let's go look up a bicycle speed. Now, bicycle speeds are kind of our functions. So let's go ahead and start at 0. And let's call the x-axis, remember this is the x-axis, but let's call it, instead of x, let's call it t for our time. Okay, so we have time here in segments. Now, it doesn't matter. This can be 1, 2, 3, 4, 5, 6. It can be seconds. It can be minutes. It doesn't matter. So I'll let you kind of judge that. Now, the y-axis is what we're going to call a function of t. So functions, if you want to get kind of used to this notations, is f of something. And on recent videos, we saw something like this. So we're going to think about this bicycle speed, and I'm going to kind of go like this here. I'm going to start at 0, and this is speed here for this axis. This is kind of like the time and speed. Now think of it, when you're riding a bicycle, does time depend on speed, or does speed depend on time? And that's something you're gonna have to think about a little bit. So I'm gonna kind of draw this a little bit, and you might want to do the same thing. Just kind of go like this, and kind of go like that, and go down. So it kind of looks something like that. Now we're going to kind of describe this graph. So this is a graph of the time in comparison with the speed of the bicycle. So it makes sense as that you're starting at 0. So here's your start. Here's your start, and your time is 0. Well, your speed is 0. So you got on the bike, and you're just gonna sit there. You haven't started, you haven't sped up or anything like that, and time hasn't ticked. And then you continue, and you go ahead and you start to ride. And then this is where it becomes quickly. So you're quickly come up here, and then you come up to here, and then this is pretty much where we have really fast. This is like the top speed right there. You're really fast because you're accelerating, so you can kind of draw some arrows. You're accelerating, and you come up really here, and you're really fast. And then all of a sudden, you come back down here, and it's what happened is that you're slowing down. So you're slowing down. Okay, so you're slowing down here, and then you kind of get to this little thing, and you're kind of traveling down here, and this is kind of where you're at what we call a constant speed. A constant speed. It's kind of when you're kind of coming down here. So here you're on the bicycle. You're starting at 0. You quickly go. You're bicycling really fast, and then you get up here and you go really fast, and then all of a sudden you kind of slow down. You slow down. Maybe you're coming to a stop, or maybe you get really tired. And at the same time, your time is clicking. Your time is going while you're riding. And maybe this is, I don't know what kind of speed, maybe this is a 10 miles an hour, 20 miles an hour, 30. Usually this is in miles per hour. It could be feet a second. I don't know. It depends on how you relate the graph to your time. So now you're kind of coming down here, you're coming down here, and then you reach here. And then what do you think happens when you reach right here? You hit the x-axis. Well, this time it's t-axis because we're relating x with t this time. So what do you think's happening right here? Well, the question is that you stop. You stop speeding, and maybe your time has stopped. So this is kind of where you stop. So here you go, you're going really fast, and then you slow down, and then you're going at a constant, and then you stop. So that's kind of what we call a function. Now this is a function, and I'm gonna show you why. Because if you kind of relate that every time of the bicycle, guess what? You have what we call an output. You have an output. So every time that you're hitting, so here's, let's say this is 4 seconds, 4 minutes. Well, this is associated to a speed. So let's say at 4 minutes, you're at what kind of speed? It doesn't matter. I'm not going to say it. But all the time is kind of what we call your independent or your input. So your time depends on the speed in miles per hour, feet a second. It doesn't really matter, but every minute or every second is associated with one output. So every second is associated with one output. Get that in your head because that's the definition of what a function is. For every input, you get one output. For every input, you get one output. For every input, you get one output. And that's really what a function is. So let's look at a rocket. Now, rockets are, if you do some physics stuff, are kind of interesting. And we have one thing working against us. We have gravity. So gravity is always a downward force. Anywhere you stand, it's a downward force. And usually if you do it in, it's about 9 meters a second, which is, meters a second down. It's what we call acceleration. Or sometimes you can do 32 feet a second. So that's in feet. This is in meters. So that I really don't want to, that's not really what the process of this is, but just think of it. Gravity is always pushing you down. So let's say that we have our axes here, and you kind of always are in the positive axes here. So let's call this height. So remember that what this is height. And this is all of a sudden, it's going to be time again because time exists. When you launch the rocket up, it depends on the amount of time until it hits the ground. So let's say you're going to launch the rocket at t of 0, so the ground. So t is 0. And what's the height? Well, the height is 0 as well. So we're going to call this axis, our y-axis, we're going to call it h of t. H of t. So the input, which is right here, this is what we call the input. That's the time. Well, each time you put a t in for the time, what happens to the height? Well, the height's at a certain position. So does it depend on time or height? What one depends on each other? Well, the time depends on its height. That makes sense. So let's think about this. If we launch a rocket up in the air and it goes something like this, and it hits the ground. Okay, so let's say that these are times. I don't know. Maybe this is in seconds. So that we have time equals seconds, and it hit the ground right here. So this is when it hit. It hit the ground again. So we're looking at, well, we launched the rocket from ground level. It goes up, and maybe this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and it hits the ground about 9 seconds. But you kind of see that from maybe at 1 Well, 1's going to go up here and be right there. Well, 2 is going to go up here and hit right there. And 3 is going to go up there and be right there. And 4 is going to go up there and hit right there. And 5, it goes right there and hits right there. And soda. So what's going to happen is that we have what we call these inputs. These inputs. We have our time is our input. And what happens, what we get out of it, is that we get out of it a height of what that t is. We get out a height of what that t is. So do you kind of see what time, every time that you're clicking, that you hit some sort of height. So this is another function for every input. For every input in time, you get an output of height. So let me repeat that again because this is crucial. This is for your definition. For every input, you get exactly one output. For every input, you get exactly one output. So you have to kind of think of it in a demonstration to kind of see what we're talking about here. And why is it so important? Well, this is key for a lot of math. This is pretty much the foundation of what math is everything's pretty much based on this topic of functions. And that's why this is actually should have been the first topic. So let's think about this here. So let's do another one. Maybe a car speed. And a car's speed is it depends what kind of city you're in, because if you're in a crowded city and you're going a lot of miles per hour or something like that, is that you kind of want to be very careful here. So let's think about this. What if our car was like this, and then it went like this, and then it went like this, and then all of a sudden it went down? So what is this axis here? Well, think of car speed. Well, this is going to be distance. Maybe that's distance this time. Or maybe this could be, well, let's make it distance. We don't want to convolute it here. And we're going to say that these are what? Well, what does distance depend on? Well, distance depends on time. So pretty much we have time through all these. And we can do some, I'm going to show you a couple more examples of functions. So you kind of see that, well, at time 0, well, what's the distance? You get in the car, you turn the car on, but you didn't do anything. You just sat there. And then all of a sudden, maybe that you go ahead and go zoom like this. That you go in 3 seconds, maybe in 3 seconds you go this distance here. So this is a d for a distance. So you're looking at right there. Maybe this is a distance of 50 feet. I don't know, 50 feet. So maybe this could be in feet. But the whole idea is that each time that you're traveling down the line, so we can kind of call this a constant speed. You know, this is a constant speed. You're not accelerating. You're just kind of constantly letting the car travel at a constant speed. But there's a distance involved. So you're going to have to kind of use a little bit of distance formula stuff here, or you can kind of look at the graph from this time to this time here and say, well, let's see, in 1, 2, 3, maybe 4 seconds, what's my distance? Well, what if this distance was 10 feet? Well, how many 10 feet do you have here? Well, 40. So this is kind of like 40 feet. So this represents a function as well, and I will go into this. I know more about this right now, but this is the demonstration of it. What's car speed? So car speeds up, goes at a constant, it maybe speeds up again, and then slows down. So this is kind of 3 examples of what a function what are. So let's go through the definition a little bit and let's kind of see what they play into, because this has a little bit of vocabulary in it as well, just kind of like everything. So let's look at our definition of a function. So we saw three graphs. So, and I said that for every input, you get what? Exactly one output. So that's kind of what I want to do here. So here we go. Our definition of a function. For every x, let's just put x for now, there is only one y. That's pretty much the basic, pretty much the simplest definition. So let's go for a little bit more. So let's add on to this. What about for every input, which you can put your x or your t, there is at least one output. And what are outputs again? They are your y's. So you can kind of see how this is playing out a little bit. So really, a function is kind of a mapping. When I say a mapping, well, it's kind of like taking some group, so let's say call it group A, and you're going to some group B. So it's kind of like you can kind of think of it this as a relation. Like a relation. It's a relation. It maps stuff from the A group to the B group. Okay? So that's kind of what's going on with this. And here's kind of pretty much the nitty-gritty, more complex definition of a function. So here you go. So a function, you might want to write this down. A function is a relation that assigns exactly one value of the independent variable to each value of the dependent variable. So let's read that again while you're reading that down. A function is a relation that assigns exactly one value of the independent variable to each of the dependent variable. So let's think about this. If that was a lot, well, that's the most complex one. But really, it's saying that for every input, you get exactly one output. That's pretty much the basic definition. That's what I would say in a classroom. For every input, you get exactly one output. So when go back up here, when we said independent and dependent, independent means your x values. Your x values. Dependent is your y values. So this is I'm gonna come up to these again, but I'm trying to express what these mean, because you're gonna get into a math class, or maybe you're in a math class and you're saying that, well, what's an independent and a dependent? And you're thinking, okay, I've heard that before, but I don't know what it is. Well, independent is a x value, and dependent depends on the y. It is the y value. So think about this. Your x's, or let's say your y's, depend on x's. So that kind of makes sense. So we're going to go through a couple of examples here. Maybe that was too broad, but let me give you some more definition stuff, because that's kind of what we're going here. So let's think about continuing on with our definition. So our definition. So here we go. We're going to put independent variable. Why do I stress on this so much? Because this is pretty much in the terminology. You have to be kind of careful with the terminology here a little bit, because when you get into, let's say that you're going into a business, or maybe you're going into a classroom, or you're going into a job, and they have definitions, but they also have terminology. So you need to know their language a little bit. So really, a definition is pretty much the language. It's just the language that we have. So it's the terminology as well. So what's our independent variables? Well, this is really what we call the input. The input. This is the x values. You could also call this the t values. You can also call this the x-axis. So really, it's really all that x-axis stuff. It's here. I'm going to try to do this. It's this line right there. It's that horizontal line. So now, what is dependent? Well, dependent is what we call the output, which is your y values. Or you can think of, remember this guy right here? That's this. This is this f of t. So let me show you how to read that. This is called f of t. This is called f of t. That's how you would read that, f of t. So you're thinking that, well, look back up here. Your independent was your t values. That's what you put in there. And what you put in there goes into the function. It works it out. And then you get an output. So here's a couple of examples. So you have your independent, you have your dependent. Now, here's a couple of examples where you would see some of this. Well, what about hours worked? Your hours worked and your amount paid. Oof. So hours worked and amount paid. What's the x? What's the input? What depends on what? Does hours worked depend on amount paid? Well, you're thinking, yeah, if I worked a certain amount of hours, I get paid. So let's make a little graph. You don't have to go a whole lot into this. Let's make a little graph. Well, what's your what's the x-axis? Well, go back up here. What's your independent variables? Your t values. So we're going to call that. This is going to be hours. That's your hours now. Well, what's this axis then? Well, if this is hours, I'm hoping that this is money paid. So you're thinking, okay, hours depends on the amount you get paid. Well, obviously, yeah. This is what we call a function. This is a function here. So let's do another example here. And let's kind of do this. What about your weight of a book? And let's say the number of, let's do pages. So the weight of the book, number of pages. So let's make a graph of that. You're going to get so good at this that you don't have to make graphs anymore, that you can kind of think about, well, what does depend? How does it depend? These are kind of easy. So what's the independent variable? Well, if you said, is it the weight of the book? I'm going to say no. What about the number of pages? So number of pages. So as the pages go up, what happens? The weight of up. So the weight goes up. So as the number of pages goes up, the weight of the book goes up. And in number of pages, I mean, there's some light the paper length, the paper weight, it could be light, but really that's obvious. If you increase the number of pages, regardless of how much the paper weighs, the book is going to increase. That makes sense. So you kind of see what's going on in a function. Like you can think, I'm hoping you're thinking about a lot more of these. Why we're going up, why we're doing this. You just kind of keep that in your head. What's that mean? So now I'm going to do a couple of problems that involve a table. So let's do a table. So here we go. I want you to kind of do this here, a table of values. Now, a table of values is something that we're going to use to make this a little bit easier. So I want you to kind of make a grid here. And make a line down, make this the first column, and kind of, I don't know, that's probably good. You might want to actually maybe increase this another way. You don't have to, but that. Put X, put Y there. And I want you to make a little, this is a table right here. Okay, no, that's very straight. Should use a ruler. That's okay. So we have hours worked. So hours worked and pay. Now if you go back, remember the hours that you work depends on the pay. So let's say we have our X and our Y. So remember what X's are. This is what? What's the X represent in this? That's our hours. So I'm going to put time for that one. And then I'm going to put money for that column. Okay? So here's what I want you to do. Put 0, 1, 2, and 3. Okay? Put 0, 1, 2, and 3. Now I want you to do this. I want you to put 0 and $15, $30, and stop right. And I want you to add one more column if you have room. And we're going to stop right there. Okay. So we're going to relate these. We're going to find a pattern of table of values. Now, hours worked. What are hours worked here? 0, 1, 2, 3, 4. Okay? Well, what's 0? At 0 hours, how much you get paid? 0. In 1 hour, how much do you get paid? Well, look at here. In 1 hour, I get paid $15. So you can find out your total that you're getting, or minimum wage that you're getting. Maybe you're getting $50 an hour. So at 2 hours, in 2 hours, how much do you get paid? You get $30. Now, I want you to kind of do you see a pattern here? Well, I'm hoping you're going to say yes. You're going to find a pattern. You're going to say, well, in 1 hour, if I get 15, in 2 hours, I get 30. Well, in 3 hours, well, that's a difference of 15. So I'm hoping you're going to say $45. In 4 hours, well, that's going to be 50, 60. Okay? Well, in 3 hours, I get there. In 4 hours, I get 60. So what I'm trying to show you that this and this are pretty much the same, just a different way of setting it up. So this is what we call a column. This is what we call a table of values. And you can kind of call them both tables. Some people do. But this is the question I want to say. So here's the questions for this. Is this a function? Is this a function? And I want you to put this. What is the independent values? What is the independent values, and what is the dependent values? So you have two questions there. Or no, three questions, sorry. So look at this. So going back, what is a function? A function was for every input, I get exactly one output. For every input, I get exactly one output. So for every input, I get an output. Do I get this? Do I get the same output for one? Well, let's say if I work 2 hours, I get $30. Well, does this make sense that if at $2 I get $15 and $30? That's kind of rough. So you might say this. Well, at $2, in 2 hours, do I get 15 and 30? No. In 2 hours, you only get 30. In 3 hours, you get 45. In 4 hours, you get 60. So you're saying that for every input, you get exactly one output. So is this a function? Yes. What is the independent variables? Well, they are 0, 1, 2, 3, 4. What is that dependent variables? Well, that's 0, 15, 30, 45, and 60. So you kind of see what the whole deal is with this, is that this is a function because for every input you get an output, but you don't get the same output for the same input. You kind of have to be really careful. So at 2 hours, I do not get 15 and 30, but I only get $30 for that 2 hours. So I'm hoping that worked out. What I want to do is try to do this next thing a little bit lightly. And what we're going to call this is called a function rule. So hold on to that. So this is what we call a function rule. So example, we're going to call this a function rule. Function rule. So really, we're going to make a table of values. Okay, so do this, please. You have your X, you have your Y. I'm going to put 0, -1, 1, 2, 3, and -2. So I have my inputs. I want to get my outputs. So I'm going to put a question mark. I don't know my outputs, but I can get them. I can get them. I'm going to put an equation right here. Y equals 3x plus 2. Remember, y equals 3x plus 2? And then I'm going to do this. Y equals 3 parenthesis plus 2. Why do you think I'm doing that? Why do you think I'm putting a parenthesis right there? Well, if you look at this table right here, these are your x values. Well, here's an x. How do you get the output? Well, there's the output. So what do I have to do here for here to get the output? Well, the reason I did this is because we're going to take this guy right here and write it there. And now we can do our numbers. So what's our output going to be? Well, what's 3 times 0? 0 plus 2. There's your output. Let's try some more. So y equals 3 plus 2. What's our input? -1. So keep going here. So y equals, well, what's 3 times -1? If you said -3 plus 2, you're in good shape. But what is -3 plus 2? Well, let's see. Isn't that -1? You're right. That is -1. So now our next one. Y equals 3 plus 2. What goes into the function now? 1. So 3 times 1, 3, plus 2, 5. Do you kind of see what's going on? So these are your input, they give you your outputs. And if you if you're good, if you would have graphed this, there's your ordered pair. If you would have graphed this, you would graph this function. If you would have graphed these points, you would get this line. So that's kind of what you're getting here. You're getting these ordered pairs. You're getting these ordered pairs. So let's think about this one. Let's keep going here. This is y equals 3 times 2 plus 2. Well, that's 3 times 2 is 6 plus that is 8. Keep 3 now. Let's see. Y equals 3 times 3 plus 2. Well, 3 times 3 is 9 plus 2 is 11. So you kind of see what's going on. Well, what about -2? Let's see. Y equals 3 minus 2 plus 2. Well, 3 times -2 is -6 plus 2. -6 plus 2 is -4. There's all your outputs. So you just kind of came up with this. So this is kind of what we call a function rule. So you put in the inputs for your x, you get an output in your y's. So to go away from this, I want you to try this one. So let's say that you work for, let's make it $20 an hour. Make a table. You work for $20 an hour. Make a table. Make a graph. Well, let's think about this. Well, here's a table. What's your input's going to be? Time, right? What's your output's going to be? Money. So let's say you work for $20 an hour. An hour. Well, 0, 1, 2. You keep going if you want. So at 0, what do you get? 0. In 1 hour, you get what? 20. At 2 hours, you get $40. Is this a function? Yes. Now let's make an equation. How do you make an equation? Well, what's the slope? So what's the slope here? What's the slope? What's the rate of change? For every hour, you get $20. For every hour, you get $20. That's what we call the slope. So y equals what? 20 times what? What do you think? X. There's your equation. So really, what you're trying to accomplish is that you're trying to take some information and make a relation to it to real life. So I'm hoping that this helped. Go through this a couple times. Functions are pretty much the basics of math. So I will see you on the next video.